Hello everyone. Today I will talk about the quicksort algorithm. Sorting is the very important skill used in computer algorithms. To implement the sorting, there are a bunch of the algorithm to achieve it. One is quicksort. Quicksort has its benefits and it don't need extra space and also provide an average n log n computational complexity. Today, I will introduce 3 ways to write a quicksort code. Let's first see the question. Given an array of integers, sort the array in ascending order. Here's one example. The array includes 5, 2, 3, 1, and the expected output is 1, 2, 3, 5. You can go to LeetCode to get this problem and try yourself. To do the quicksort, first let's see the algorithm structure. For the quicksort, the input is the array. P stands for the starting pointer and R standing for the ending pointer. It means that we will use this sort the array from the pointer P to R. The first step, we get a partition. And having this partition, we get a pivot. And then the pivot will split the whole array into 2 parts. And then we can call the quicksort on the first part and on the second part. You can see this is the divide and conquer method. We can see the right side of the picture. First, we choose the last element of the array as pivot. Here is 3, and then the whole array is split into 2 parts. The first part is smaller than 3, and the second part is greater than 3. And then for each part, we do the similar operations for this quicksort. For example, for the first part, the last element is 1, is marked in the red, and then we also split that part into smaller than 1 and greater than 1 until all the elements are sorted. In this quicksort architecture, the most important part is partition methods. Here is one implementation of partition method. This is from Introduction to Algorithms book. For this partition method, I pasted the pseudocode here. You can implement it by your familiar language. The idea is having this array, we choose the last element as the pivot, and for the whole array, we have 2 sections. The light gray section is elements smaller than the pivot. The dark gray elements are the elements that are greater than the pivot. So as the last step, we just exchange the pivot into the middle of the array, and then return this pivot position. So this is the partition methods. Second partition methods is a little different. This is from Algorithms 4 book. For these partition methods, we introduce I and j as a pointer, and then when in the middle of the calculation, from the element 0 to I is those elements that are smaller than the pivot. For the elements j to last elements that are greater than the pivots. And do this calculation until the I and j meet with each other and then can stop. As the last step is also exchange the pivot into the middle of the array and then return that pointer. For the previous 2 solutions, we have also used the same algorithm architecture, and use two ways to implement partition. Here we introduce another quicksort method, and here's the steps. Its first is let left equals low and right equals high, and the pivot is the first elements. And also when the nums left less than the pivot, move left pointer. When nums right greater than the pivot, move right pointer. Then after above movements, the left elements and the right elements, they should be exchanged. And we do these steps until left meet right pointer. So using this method is different from the previous one because when it's loop ending, it has two possibilities. It's not the same as the previous one. When previous two algorithms, when the loop ending, it get one element and that element is the pivot. But for this algorithm, when loop ending, it has two possibilities. One is that right pointer and then left pointer, and the other case is the right pointer and the elements and the left pointer. For that elements in the middle is should be equals with the pivot value. So I will demonstrate writing the code for this sort 3. Let me demonstrate how to write that quicksort algorithm. Here I use the lead code, and for this method I want to use quicksort, and this will called quicksort. For this quicksort definition, the input include the arrays and the first low pointer and high pointer to define that range of the array. It needs a response, so we just response the inputs because we will do the in-place sorting. Otherwise, you may create a new one and then sort the new one. For this quicksort, the first, if low is higher than the high pointer, we just return. We don't need to do the actual work. And below, for this algorithm, we don't have one pivot, but we have two possibilities. So let's see. We use left equals low, right equals high, and then choose a pivot. This pivot is a value, and is equals. We choose the left one. Left, right, and we want to move these 2 pointers into the middle from the leftmost and the rightmost.